Hi everyone, welcome to this episode of Data Epoch. We have Divya Chinnappa here with us today. She is a natural language processing and machine learning researcher. Currently, she works for Thomson Reuters as a research scientist. Her current research focuses around legal natural language processing. She is also very passionate about low resource natural language processing project, and she is currently working on Tamil natural language processing projects as well. Thank you so much, Divya, for being here with us today.
Thank you, Sanjana, for having me.
So, how and why did you get into data science?
Okay, so I got into data science because of my PhD. I did my PhD in natural language processing. So, like, this kind of led me to data science. And I enjoy the entire process of data science from collecting data, which includes annotating, calculating disagreements, and then analyzing the data set, feature engineering, model building, error analysis, and finally deciding which model should go into production. So I like this entire process. I like every part of the process, and work is fun. And every day I learn a lot. And with every part of the project, as I learn a lot, I'm happy with what I'm doing, and it pays well. So that is why I am in data science. And it feels really good to know that I kind of understand how the current technology and AI works. And I'm also happy and satisfied that I get to play a role in the future of technology. And this is why I'm in data science.
Awesome.
Yeah.
So, how did you transition into this path, and how did your previous experience set you up for this role?
Yeah, as I mentioned earlier, I'm an NLP researcher, meaning language is the data I work with. So my love for language brought me into NLP, which actually brought me to data science. So I received my bachelor's and master's from India from Anna University, and soon after my master's, I worked as a lecturer in Anna University constituent colleges. During this time, I was teaching regular expressions to my undergrad students, and I was learning more about regular expressions. So I learned about how regular expressions could be used in languages, which kind of opened up the broader area of NLP.
Mm-hmm.
And both my bachelor's and master's are in computer networks and cryptography. So this is sometime around 2012. And but as I learned more about regular expressions and NLP, so I thought I found NLP very fascinating. So I started working on NLP with Python. Like I started trying out basic Python comments for NLP. And at some point, I decided I should do my PhD in NLP. So that is how I ended up getting a PhD in NLP. It was really a hard path because I had to transition from computer networks and cryptography to NLP. But I'm very happy that I'm here. So basically, in a nutshell, my love for language, like trying to understand language semantics and pragmatics, brought me to this path.
That's a very inspiring trajectory. Thank you for sharing that. Can you
Mhm.
tell us about a very cool project that you worked on?
Yeah. So I worked on multiple data sources like tweets, YouTube comments, blogs, Wikipedia, telephone conversations, etc. But in my current job, I get to work with legal NLP, which means I work with cases from US courts. So it's like long text.
Mm-hmm.
And I try to extract a specific information from a case or identify relationship between cases, which is like so much fun for several reasons. The first thing is the way legal experts write the language, right? Like it's like, why do they have to write it this way? Why can't they be simple, right? Like why can't they write it? But that I enjoy working on legal natural language processing for the way the syntax is. Like it's not like how we actually speak. So yeah, I'm not going to get into the details of the projects that I worked, but another project that I found very interesting is when I worked with tweets. um, so when I was in university, I, along with one of my friends, we tried to understand why people tweet with the hashtag fail. So usually, sometimes people have hashtag fail, and we are trying to identify why people tweet that. Why would somebody boast about a failure, right? So we began this project trying to understand why people do that. So we were targeting specific events, and we were like looking only at baking and cooking events, and we were collecting tweets that involved a baking event or a cooking event. Maybe they were baking a cookie, or they were making some biryani or something like that. And why did they have the hashtag fail? So we were looking at the images and the text together, and we noticed that most of the time the product or the food is actually good. So usually the hashtag fail is sort of a humble brag saying that, okay, it didn't come out as I expected, which means they have really a high bar. But it looks good. Like, and the comments will be like, "Oh, come on, it looks nice. I'm sure this is yummy," and things like that. And sometimes people have a hashtag fail because like they completely burnt out something, or there is a device failure, like they forgot to turn on the gas stove. So like there is something beyond the failure that they are trying to say. So like the point is that even though people have a hashtag fail in their tweet, it's not that the event ended up in a failure. It's that there is something behind the event that the person is trying to say. So I enjoyed working in this project, and yeah, I mean, it is a EMNLP 2020 findings paper. You can go read it if you want to. It's fun actually.
That's awesome. So, what advice would you give someone new to data science and machine learning?
Yeah, I would say to learn the basics thoroughly. I'll speak from an NLP perspective. So I would ask people to look into data, right? Like you don't have to right away start with a BERT model. Look into the data, and maybe start with a very simple model, like a TF-IDF feature with a simple logistic regression, or maybe a tree-based model could work. So I think we need to set a strong baseline based on traditional models, and then we can go into all these transformer models and maybe do fine tuning or whatever you feel like doing there. But I wouldn't encourage to just go start with the transform model for several reasons. One thing is the carbon footprint that is involved in this. Like we don't want to be a part of like global warming and stuff. So yeah, I mean that's beyond the scope of this podcast, I would say. But then we should be setting up strong baselines with traditional classifiers first. And the next thing I would say is to make sure that there is no data leakage. Several times when we work with the interns or like young researchers, like they leak data and then they are excited about the results, and sometimes the results are accuracy, right? Like they bring results based on accuracy. So it is very important that we choose the right evaluation metric. You may have like a 99% accuracy, but your data might be like highly imbalanced. So we should know to choose the right metric. And then I think beyond that, follow standard practices, right? Since we are kind of a part of the future in building this entire AI world, I think it's necessary for us to be mindful of the ethical considerations, like follow standard practices, like write a data statement if you're building a data set, and if you're building a model, have model cards, like make sure everything is documented. So this is something I would encourage beginners to do. And from a learning perspective, I follow two things. Like instead of reading something from a random log, just go to the actual paper, right? Like, if, for example, if you have to learn about BERT, just get the actual paper written by the authors and read it. And that would give you more insights than the several blogs. I mean, there are some really good blogs about uh, these technical papers, but then I prefer going and reading the paper written by the author themselves. Yeah.
Awesome. So, how do you stay updated with all the advances in the field, given that it's like a growing field, and do you have an upskilling plan?
Yeah, so most of the time it's demand based. For example, I was currently working on an NLP project, which was like completely depending on the text. And while we were working on this project, we realized that there could be features that are outside the actual text document, like the court cases. So there could be other features that we could get from other cases as well. So which made me learn like graph neural networks, right? Like right now I'm looking into graphs. So one thing that happens naturally is demand based. Depending on what your project is asking, I'll go read those things. Another thing I follow is I whenever there is a conference, usually I follow the ACL conferences closely. So whenever there is a conference, I keep watching Twitter. So there are usually tweets like nice summaries of paper. Like there are volunteers in the conference who write summaries for papers. So you get to read you get the idea of a paper in maybe like 5 or 6 tweets. So this is not a traditional way to be updated about what's happening around, but then I look into tweets about the popular papers and I go read those papers. And then sometimes I'm currently taking a course in Udemy, like as I mentioned, like for graph neural networks. So like depending on the demand or maybe what's happening around the world, I pick one course. I don't try to learn everything. I know it's not possible to keep up with everything that's happening in the AI world. So I'm taking one thing at a time and I'm taking it slowly.
Awesome. So tell us more about yourself, like outside work, what do you enjoy and get inspired by?
Yeah, so I like gardening. Like I live in a very cold place. I live in Minnesota. It's like snow like 7 or 8 months a year, but still I have like so many plants in my house. I do that, and I enjoy visiting museums. So again, this is because of my NLP work. So there was a time I worked on popular paintings like Mona Lisa and Guernica. Basically, I took the Wikipedia articles of these paintings and I was analyzing the text there, during which I happened to read the entire Wikipedia article and I sort of felt love in history. So I never liked history when I was in school, right? It was like a boring subject and I never understood why we have to learn history. But right now, I'm so much into history and I enjoy visiting museums. And I'm a member of any sort of historical museums near me. And I go there and I imagine how our ancestors lived. Like, for example, right now I'm in North America and I go there and like when they tell us about like how the Native Americans lived in this particular place, it kind of is very inspiring, right? Like how our ancestors spread, like how Homo sapiens spread across the world, how we built all these technologies, and like kind of very thankful to our ancestors for bringing us here today for every technology that they built. So I enjoy history and I enjoy visiting museums. And then I have a kid, so I go along with her to playgrounds or like all those aquariums and stuff. So basically, yeah, that's how my life is outside work.
Very cool. So yeah, there's a lot to unpack here. For example, how data like sort of captures so many layers that help you solve the problem and taking the time to understand that before going ahead to devising the solution and just explaining the beauty of natural language or human language, right? This is also something that I mentioned in one of my courses that uh, natural language is one of the most exciting data you can work with because
Right.
there's so much context and information richness present inside, and even to start digging it is so much fun. It's very mentally stimulating and very fulfilling when you get to solve the problem uncovering all of these stories.
Yeah.
So it's been very insightful. And finally, just one question: since you've been both in the academia and industry,
Mhm.
do you notice like any sort of differences in the research scene in academia versus industry for NLP?
Yeah, right. So the difference is that in academia, all we do is, we want to bring the best results possible, right? We need to build several models, or maybe build a model that is performing better than what the previous paper has. So the goal would be to eventually write a solid paper like honestly speaking, like while we try to solve a problem, the goal is to write a solid paper about either releasing a data set or maybe building a model or like some sort of technique. That is the goal there in academia. But when it comes to industry, it's all about product. It's about satisfying the customer, right? Your model might give you like a really high F score, let's say I'm getting 85 F score, but if the remaining 15% where the model is wrong, if it is absurd, it is going to affect your product. So there is like the difference is that we need to make sure the product is like good enough for the customers. So yeah, so when I first came here, like I was kind of surprised to learn the time that is spent in building a really good model. Like, and you need to consider about everything. Like when in academy you can take a data set and start working. Here you need to think about IP issues. Can I actually use this data set? Can I actually use this particular model? And yeah, the biggest difference I found is like after you built a model and after your model is successfully predicting things, it might look good in numbers, but maybe the customer is not satisfied.
Mm.
So satisfying the customer is the goal here. It does not really matter if you use a transformer model. A traditional model would be sufficient in industry as long as you get a really good result. But in case of academia, you cannot just go say, I mean, people are trying to say that right now, right? Like, uh, but you cannot just go say that I built a logistic regression model for this problem, and you cannot get a paper out of it. So yeah, that's the difference.
Yeah, and I think that needs to change, right? As long as
I
we solve
agree.
problems, yeah.
Of course, I agree. Yeah. I think simplicity is the way to go. We don't have to overcomplicate things. I mean, sometimes, there are times where we don't need a machine learning model, right? Like when a problem is put in front of us, why can't we just go with a rule-based algorithm, right? Like, so that is the biggest question I see, especially with, like you asked earlier, like with new researchers and new people, beginners in machine learning, we need to ask ourselves, is this even necessary? Like, why can't we just have a rule based model and see if it works? Yeah.
Yeah. Well, thank you very much, Divya. All of it was very insightful and, really straightforward. So thank you for being here.
Thank you, Sanjana. It was fun. Thank you for having me. Bye
Okay.
bye.
Bye.